Hi all, I am Madam Kong. This is my second virtual revision class with you all. The purpose of this video is to discuss the latest 4-set PSPM past year question. The topic we are going to discuss is Chapter 2, Thermochemistry. The percentage for Paper 1 in this topic is 3 out of 40 questions, and Paper 2 is 14% out of 100%. Let's start our discussion with the latest set, PSPM, set 2018-2019. This is the original question. Follow the latest format. Let's start. Analyze the question. In an experiment to measure the enthalpy change of neutralization, 25 ml of 1.0 molar HCl is placed in a polystyrene cup. At the same temperature, 25 ml of 1.0 molar sodium hydroxide is added and stirred. Based on this information, we notice that the total volume of this solution is 50 ml. Next, the temperature of the resulting solution increased by 7 degrees Celsius. So here is the information about delta T. Calculate the enthalpy of neutralization for this reaction. So meaning that if enthalpy of neutralization is referred to 1 mole. 1 mole of what? If you still remember the definition of enthalpy of neutralization, so it's referred to 1 mole of water is produced. Continue. Assume the density and specific heat capacity, small c, of the final solution are the same as water. So based on the information given, we know that we need to use the formula MC delta. M is referred to here. C is referred, we can get the C from the question paper, and T is referred to here. The second part of the question, so thermochemical data for the formation of sodium oxide and N2O is given. So we need to construct a Born-Haber cycle for sodium oxide and calculate the enthalpy of atomization of sodium. Let's check the solution. First, we need to understand the situation of the question. So in this situation, heat released by the reaction is equal to heat absorbed by the solution. There are two solutions, which are HCl and NaOH. So first, based on this statement, we convert it into formula. Heat release Q is equal to MC delta. So M is 50 ml, so equal to 50 gram times specific heat capacity times delta 7 degrees Celsius. So the answer is 1463 joule. Next, we have to write down the equation. Based on the equation, 1 mole of hydrochloric acid react with 1 mole of sodium hydroxide, produce 1 mole of sodium chloride and 1 mole of water. Based on the definition of heat of neutralization, we refer to the 1 mole of water is formed. When for the heat release. Step 3, we need to find the number of mole by using N equal to mV per thousand. N 1 molar, V is 25 ml, must convert to liter, 0.025 liter. So the number of mole is 0.025 mole. Since both N of HCl and N of NaOH is the same, so we no need to determine which one is the limiting reactant. So 0.025 mole of water produce this amount of heat. Now the question asks about enthalpy of neutralization. So it's referred to 1 mole. So we need to compare with stoichiometry method. So this is a calculation. So get 58520 joule. So the last step, we need to answer the question and make conclusion. So the enthalpy of neutralization is equal to, negative sign is insist because heat release. 58.52 kilojoule per mole. Next, we follow by construct a Born-Haber cycle for sodium oxide. First, we must form the equation for enthalpy of formation. So, the product is sodium oxide. Sodium with positive 1, oxygen with the charge of negative 2. So that's why Na2O. So here, 2 mole of sodium react with half mole of oxygen and then produce 1 mole of sodium oxide. Make sure the phase of each atom or each compound is correct. Sodium solid, oxygen gas, sodium oxide is solid. So this is the enthalpy of formation. Must write down the negative and positive sign for the enthalpy. So 414 kilojoule. Or the Born-Haber cycle, the final unit, the unit we write down is kilojoule, 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 kilojoule. Okay, next, from the sodium solid, undergo atomization, become sodium gas. So the enthalpy of atomization, based on the question, is given in 1 mole. So we need to times 2 because here 2 mole. Same for ionization energy. There are 2 mole of sodium gas become 2 mole of sodium ion gas. So we need to times 2 as well. Okay, here is the atomization for oxygen. So become oxygen atom in gas. Next, here at 1 mole of electron is added. So first ionization, first electron affinity, which is negative 141 kilojoule. And then second electron is added. So second electron affinity, positive 750 kilojoule. So this is the ion. And then it will form the lattice energy. So this is the complete Born-Haber cycle for sodium oxide. Next question asks about the enthalpy of atomization for sodium. So as I guide you all before, we need to write down this relationship and then only substitute and then make the conclusion, the final answer. Enthalpy of atomization of sodium is positive 107 kilojoule per mole. So for the last part, the unit is kilojoule per mole because it's referred to 1 mole of atomization of sodium. Okay, let's discuss the PSPM set 2017 and 2018. Okay, this is the original question. Okay, let's analyze the question. So given standard enthalpy formation of NO with this value, NO2 with this value respectively. So the first question asks in general, what the definition of standard enthalpy of formation. Okay, second question we need to explain. Okay, by referring 1A1, why the standard enthalpy of formation for element is 0. So 1A1 is asking about formation. Okay, if you refer the formation, the definition of enthalpy of formation, right, is the heat change when 1 mole of a compound is formed from its element in their stable state under the stated condition or standard condition. So in this case, we need to emphasize one element, the enthalpy is 0. Okay, 3, have to write the equation for the enthalpy of formation of NO and NO2 is thermochemical equation. 4, determine the enthalpy change of the following reaction. So this how to form this reaction by using an energy cycle method. Okay, let's check the answer. So the definition should be no problem. Heat change when 1 mole of compound or substance is formed from its element under the most stable state at standard condition, which is 25 degrees Celsius and 1 atm. Okay, what is element? Actually, right, the element like sodium, magnesium, oxygen gas, always is 0 because, right, all of these elements already exist in nature and there's no heat change is involved from the formation of itself. Okay, so the answer given here, elements are formed from their respective atom or element. Okay, same what I explained just now, they are exist in nature, so no heat change is involved from the formation of itself. Okay, you can check your textbook. For those who have textbook, right, page 29, point number 6. Okay, next, write the thermochemical equation. So enthalpy of formation, meaning that 1 mole of NO2 is formed. How NO is formed? From nitrogen gas and from oxygen gas. Since here is 1N, so half mole of nitrogen gas and half mole of oxygen gas. So NO2, so half mole of nitrogen gas react with 1 mole of oxygen gas and then form NO2 gas. Don't forget, must write out the enthalpy because this is thermochemical equation. Positive sign insists, and then the unit is kilojoule per mole. Kilojoule per mole for the thermochemical equation. Okay, next. Determine the enthalpy change, okay, based on this equation. So let's check. Here is the enthalpy of reaction for NO gas react with oxygen gas and then form NO2 gas. How NO is formed from? If you look at this one, right? Okay, let's check. If you look at NO, actually it's from here. Okay, initially it's half nitrogen gas react with half oxygen gas form 1 mole. But based on this equation is 2 mole. That's why the whole thing's already times 2. And one more information, the sign of the arrow reverse. So that's why here positive. And then when you reverse the equation, the sign of the enthalpy will change as well. From positive change to negative. Okay, next here. Okay. Form 2 NO2. 2. So we need the whole equation also need to times 2. So 1 mole of nitrogen gas react with 2 mole of oxygen gas and then form 2 mole of nitrogen, 2 mole of nitrogen dioxide gas. So you need to times 2, here also need to times 2, and then this one reverse. So based on the formation of this energy cycle diagram, so you notice the enthalpy 1 plus the enthalpy 2 equal to the enthalpy reaction. So you must write out enthalpy of reaction equal to enthalpy H1, enthalpy H2. So substitution, and then the final answer is negative 113.14 kilojoule. The unit from PSPM set 2016-2017. Okay, this is the original question. Analyze the question. The combustion of ethanol. So combustion, you know the enthalpy share is negative value. For ethanol is C2H5OH. Occur according to the following reaction equation. So the equation is given. So react with oxygen. Okay, this is combustion, react with oxygen, and then form CO2, H2O. So when 3.68 gram sample of ethanol was burned, so the mass of ethanol is given. So this is a molecular formula for ethanol. Sure, we need to find number of mole for ethanol. In excess oxygen in a bomb calorimeter. So bomb calorimeter in this case, so meaning the heat capacity is involved. The temperature rose from 25 degrees Celsius to 66 degrees Celsius. So this is the delta T. So first, define enthalpy of combustion of ethanol. Second, found the heat capacity is given. So calculate the enthalpy of combustion. So is there any mass or solution over this question? No, right? So the formula that we are going to apply is this one. C delta T. Let's check the. Okay, let's check for the solution. So A1, define the standard enthalpy of combustion of ethanol. So the answer for this definition must towards ethanol. So standard enthalpy of combustion of ethanol is the heat release when 1 mole of ethanol is burned completely in excess oxygen as standard condition. Don't forget to define the standard condition, which is 298 Kelvin and 1 atm. Okay, next question is related with the calorimeter. So based on previous question, okay, the 2018-2019, we start with formula. In this case, we start with finding number of mole of ethanol. It doesn't matter, up to you. So we start with finding number of mole, so by using mass over molar mass and get 0.08 mole. Make sure, right, okay, if this, because the answer is really exactly 0.08, that's why only 2 decimal places. If possible, right, this is not the final answer yet. Always remember, stick to 4 decimal places. Okay, next we look at here. Okay, so we have to understand the situation of the question. So heat released during combustion is absorbed by the calorimeter. The heat is absorbed by the calorimeter. So this formula is applied, substitution, and then you get the answer. Okay, Since the heat capacity given in kilojoule, that's why the final answer is in kilojoule. Okay, next step, we compare by using stoichiometry method. Okay, 0.08 mole release negative 81.18 kilojoule. So now the question 1, enthalpy of combustion means 1 mole of ethanol. So stoichiometry, you get the answer negative 1014.75 kilojoule. Don't forget to make the conclusion. The enthalpy of combustion is negative 1014.75. Finally, we need kilojoule per mole. The negative sign insists, and then the final unit must kilojoule per mole. Let's discuss the last question for PSPM set 2015-2016. A boom calorimeter contains 780 grams of water, an amount of 2.34 gram benzoic acid, okay, with the molecular formula C7H6O2 is burned in calorimeter. And this caused the temperature to increase from, okay, so here is the hints for us to find the delta T. Okay, calculate, okay, energy released in kilojoule if heat capacity of the empty calorimeter is 870 joule per degree Celsius. So here we need to apply the formula C delta T. For here, right, the mass water is given, so meaning that we also need to apply the formula MC delta T. And then next, we need to find out the heat evolved per mole of benzoic acid. So this question is related with calorimeter. Okay, let's check the. Okay, first you must understand the condition of this question. The heat released during combustion is absorbed by the calorimeter and absorbed by the water. So the formula that apply for this condition is Q reaction equal to C theta plus MC theta. So step 1, write down the formula. Then you substitute based on the information given and then get the answer in joule. So then you can convert it become kilojoule by divided 1000. And don't forget to make the conclusion. Energy release is 45.85 kilojoule. Okay, next, heat release or heat evolved per mole of benzoic acid. So for 1 mole benzoic acid, so before we know what is the heat evolved for 1 mole, we must know how many mole evolved for this question. So we must use the mass given by the question divided by molar mass. So it's 1.918 times 10 to the power of negative 2 mole. So this is the step to find out the number of mole. Actually, right, for step 2 equation is not really important for this question, but I encourage you all use yourself to follow the step. So just write down 1 mole of benzoic acid burn completely, okay, burn in completely with excess oxygen to produce CO2 and H2O. Just balance it. Okay, then you proceed for the step 4. Based on this question, 1.918 times 10 to the power of negative 2 mole released negative 45.85 kilojoule. So you just use a stoichiometry method calculation to calculate the 1 mole of benzoic acid will produce how many mole of kilojoule. So the answer is negative 2390.34 kilojoule. So at last, step 5, answer the question and make conclusion. Heat evolved per mole of benzoic acid is, so the enthalpy of combustion is, negative sign insists negative 2390.34, refer to 1 mole, so it's kilojoule per mole. So this is the final answer. Actually, right, for this chapter, divide to 4 parts. You just try to redo again your tutorial question. It's quite good. The tutorial question is quite good. We'll divide to 4 parts. First, definition about the enthalpy. Second part is about the calorimeter. Please try all the calorimeter question again from the tutorial. And then the third part is about the energy cycle method or algebraic method. And then the fourth part is about energy algebraic method. Energy level diagram or energy Born-Haber cycle. Okay, continue fighting. Don't give up. Good luck.